Today we're going to graph absolute value equations. Absolute value equation, when we graph them, we're going to end up giving us a V shape. And we're going to figure out how to get that today. So in order to start, like with parabolas, you always want to find that vertex. Now in order to find that vertex or that axis of symmetry, that spot in the middle, we have to go inside the absolute values. So we're going to take what's on the inside and set it equal to 0. In this case, we have x minus 4, set it equal to 0, add 4, x equals 4. That 4 that we just found now needs to come right in the middle. And like with a parabola, we always found numbers above that axis of symmetry and numbers below. We're going to do the same thing. So we're going to go 3, 2, and I don't know how many spots we're going to go. So we're going to go up to 1. We'll do 3 there, and then 5, 6, 7. So we're going to take each one of these coordinates, or each one of these x values, substitute them in, and find its matching y value. So let's see where that goes. Let's plug 1 in. 1 minus 4. So 1 minus 4 is going to give us negative 3. But remember, all of that is inside the absolute value, so that's now going to give us a positive 3. I'm going to do the same thing with a 2. So I'm going to put a positive 2 in there. 2 minus 4 gives us negative 2 inside the absolute value, which then when we take it out, gives us positive 2. Keep going. We're going to put a 3 in there. 3 minus 4 is going to give us negative 1. The absolute value of negative 1 is just 1. Okay, and now that spot that's in the middle, we put that 4 in there. 4 minus 4 gives us 0. The absolute value of 0 is 0. Okay, let's see what happens once we cross that threshold, once we cross that vertex spot. Plug a 5 in, 5 minus 4. Now it's going to give us a positive 1. Absolute value of that, going to be a positive again. I think I have an idea of what's going to happen here. If we put a 6 in there, 6 minus 4 gives us 2. The absolute value is going to give us a 2. And if we could just take a guess, the next number that we plug in, a 7, is going to give us a 3. So we have all of our coordinates. Now let's plot them. We're going to go to the right 1, up 3, go over 2, up 2, go to right 3, up 1, over 4, up 0. All right, go to the right 5, up 1, over 6, up 2. And now I just happen to run out of space on my graph, which is fine because I can still tell that my graph is going to form that V. That's good. So let's try it again with something a little more complicated on the inside. So this time we have 2x plus 1. Again, let's start it off by setting the inside equal to 0. We're going to say 2x plus 1, set it equal to 0. Minus 1, 2x equals negative 1. X equals negative 1/2. Now, I know we don't like fractions, so we're going to deal with them as little as possible. Like with the problem on the first problem we did, and like with parabolas, when you find that vertex, you want to take equal steps outwards from that middle number. So I want to take equal steps out from here. So what's a number smaller than negative 1/2? I'm just going to go with negative 1. We took a half a step in that negative direction. How about a half a step in the larger direction? You get 0. And now we can take our full steps, negative 2 and 1, and maybe we don't need to go any further. So we're not going to go. We'll just do those ones. So let's plug all 5 of these in up here. Now, we also notice that the bottom half and the top half, the y values matched up because we took equal steps from that center. Let's do the same thing. Same thing's going to happen here. So instead of plugging in all 5, I'm just going to do these bottom 3. So let's plug 1 in up there. We're going to say 2 times 1 plus 1, all in absolute values. That's going to give us 2 plus 1, which is 3. And the absolute value of 3 is just going to give us 3. So we plug the 1 in, we get a 3. If you plug a negative 2 in, you're going to get the same thing. So let's do it again. This time, let's put in 0. 2 and 0 is going to give us 0. 0 plus 1 gives us 1. Absolute value of 1 is still 1. So look at that. Much quicker. Now we've got a problem. Now we get that fraction. So here's going to be a little bit of work. 2 times negative 1/2 plus 1. So turn that 2 to a fraction. Now you're going to have a negative and a positive. Going to give you a negative. These 2's cancel out, and you're left with just that 1. And then plus 1 gives us a 0 on the inside. Absolute value of that is a 0. So, okay. Fraction wasn't too bad. Now, let's plot all that. Go back 2, up 3. Go back 1, up 1. Here's where it gets a little weird. Go back a half, go up and down 0. Go over 0, go up 1. Go to the right, and then up. And you can still see a V forming. And we put those arrows on the end because this graph keeps going on and on forever. All right, so what if you have a fraction already in the inside? Not that we got an answer as a fraction, but we have one to start with. This is actually maybe a little easier. So let's take inside, set it equal to 0. 1/3 x plus 2 equals 0. So minus 2, 1/3 x equals negative 2. And now to move a fraction from one side to the other, multiply by 3, or 3 over 1. Those 3's cancel, you're left with x equals negative 6 this time. Okay, so negative 6 in the middle. All right, I want to pick numbers smaller, I want to pick numbers larger. Now there's going to be special numbers that I'm going to pick this time. I could do negative 7, negative 8, negative 9, but when I plug negative 7 in there, I'm going to have 7 over 3. I don't want to deal with a fraction, so I'm going to simplify this for myself. And I'm going to look for multiples of 3. So when I multiply it by that 3, things cancel out. So I'm going to go for negative 9, negative 12. You could go to negative 15. On the other direction, I went down 3, and now I want to go up 3. I'm going to say negative 3, and then 0. So I took those equal steps. Now I want to plug all 5 of these, or really just 3 of them, into my problem. All right, let's start with 0. I like 0. Cancels things out. So 1/3 times 0 plus 2, all that's inside. You get 0 plus 2, which is still 2. Absolute value of 2 is going to give us 2. Because we took equal steps, I'm going to get a 2 up there. Let's do it again. Instead of a 2, now we're going to plug in negative 3. All right, so you could turn that to a fraction. A negative and a positive gives you the negative. These 3's cancel out, and you're left with just 1. So negative 1 and 2 gives you positive 1, absolute value of that. Positive 1, same thing happens with the negative 9. And can we do this with negative 6 now? Negative 6, turn it to a fraction. My answer is going to be negative, a negative and a positive. 6 divided by 3 gives us 2. Negative 2 and positive 2 gives you 0. Absolute value of that is going to give you 0. All right, there's all the hard work. Now we got to plot this. So back 12 up 2. I don't know if I'm going to have enough room. 1, 2, 3, 4, 5, 6, 7, 8. I could do 9, so let's just go there. We'll go one more. So 9, back 9, up 1. Back 6, 1, 2, 3, 4, 5, 6, up 0. Back 3, up 1, and over 0, up 2. Okay, so it doesn't look like much, but we could still connect them. And we have a very flat V, but it's still a V. And that is graphing absolute value equations.